Hello students, this is Shweta Patil and I welcome you all to the video lecture on computer organization. We were discussing about module 3, that is memory system, and in this video I will be explaining you about the performance considerations which can be done by explaining about interleaving and other methods of improving the performance. So here we go. So performance consideration. Which are the factors on which the computer performance depends? The commercial success of a computer, the success of a computer depends on the performance and its cost, isn't it? So we opt the one which is providing the best possible performance with lower cost. That is the main objective. The key design objective of a computer is what? To achieve the best possible performance at lower possible cost, isn't it? And the measurement of the success is on performance price by performance ratio. The measurement of the success can be done by price by performance ratio, which you can look at, isn't it? So the performance of a computer usually depends on how fast it executes, which is nothing but how fast the machine instructions can be brought into the processor for execution and how fast the instructions can be executed, right? So now this fastness or performance now or it depends on the accessing of the instructions or data from the memory or the speed with which the memory accessing can be done, right? So this accessing can be improved, the performance can be improved by improving the access speed, right? And that can be achieved by improving or adopting the parallelism within the accessing of the data or instructions from the memory. This parallelism can be adopted by using a method called as interleaving. Okay, so the main memory can be thought of as a collection of separate modules. Each of these modules will be having their own ABR and DBR. What ABR indicates? ABR is nothing but address buffer register and DBR is nothing but data buffer register, right? So the memory access operations may proceed in more than one module at the same time. If we consider the memory as physically separate modules, I can have accessing of these modules separately. Okay, by more than one module accessing can be done and that will speeden the operation of accessing, right? So now we have two different ways, two address layouts are there which will be explaining this parallelism, right? So in this first case, this is the first case, the memory addresses are how the consecutive words are stored in a module. What is this case? This case is showing consecutive words in one module. Consecutive word means assume I have 5 words 0, 1, 2, 3 and 4. 0 word, 1 first word, second word, third word and fourth word. These are the 5 words. All these 5 words are now named as consecutive words because they are lying one after the other, isn't it? So these are the consecutive words and these consecutive words are placed only in one module. Within a single module all of these are placed, right? So these words, how they will be accessed? I need the consecutive words 0, word 1, 0, word 1, word 2, word 3, word 4, all these words are to be accessed now. But in this method all the 5 words are within a single module. This module, in this method, see you are having the first k bits of the addresses generated by the processor. Processor has generated the memory module address. You can look in the figure. It has been divided into two fields. One is k bits will be deciding the module and the lower m bits will be deciding the address in the module. That means in one module I can get all the successive bits, all the successive words, right? So if I need the words, consecutive words, I will be getting from one module. Assume module 0 contains all these 5 words. So all these are accessed by the processor. How I am fastening the operation? The question is here. How I am fastening the operation here? That is, if any of the other input or output devices wants to have inputting or outputting through DME, DMA doesn't include processor. Processor is performing its operation in module 0. So, the DMA can use, or any other device which needs input output operation through DMA can opt, assume module 2 or module 3. So, more than one module, more than one word are accessed at the same time. One is accessed by the processor and other is under processed by the DMA operation, isn't it? Thus, I am achieving parallelism in the first case. In the first case indicates in this case where consecutive words are stored in a module, isn't it? So, we are providing one by using processor and one is by DMA ability. So, we can have access to more than one words at the same time, which will improve the performance of a computer. But even more is achieved by interleaving operation, which is shown here. You can look at. See, here what happens is the address bits sent by the processor, the main memory address bits are first, the higher first m bits are divided for address in the module and lower k bits will decide the module. So, first will decide the address in a module. First module may be 0th module, first module, second module, likewise it may, address in the module may be the first location within that module, second location within the module. Module is determined by last k bits, the lower k bits. So, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, likewise different modules will come here, right? Different modules will be there, fine. So, now the successive consecutive words, 0th word is placed, assume in 0th module, first word is placed in first module, second word is placed in second module, third word is placed in third module, fourth word will be placed in fourth module. Likewise, I have stored the 5 words in 5 different modules, word 0 in 0th module till word 4 in 4th module, right. So, thus I have placed 5 words, but at a same location now, maybe at first place or second place, third place within that module, isn't it. Now, how this improves the performance? Assume I want to access these 5 words, word 0 to word 4, then all of those words are placed in different modules and they can be accessed at the same time. So, instead of getting only one word at a single time, I can now fetch all the 5 words at the same time. This is what parallelism is. Thus, it increases the speed with which the accessing of memory can be done, and thus it reduces the consumption of time to access the data or the instructions and helps to improve the performance of a processor, isn't it. So, this is how we can explain interleaving concept which improves the performance of a computer. See, normally what happens within this, we have to get through the terminologies as hit rate and miss penalty. Whenever a read operation or a write operation has to be done, first the address will be sent and that particular address will be, the data will be stored. If it is stored in the cache, it will be taken from the cache. If it is not in the cache, it will be taken from the main memory, stored in the cache, and then it will be accessed, isn't it. The process I will be explaining. See, whenever a read operation or write operation has to be performed, whenever accessing has to be done, first it will be searched in the cache memory, isn't it. If successful access of the data is there in a cache, then it is called a hit. Successful access to data in a cache, then it is a hit. Okay. So, what is hit rate then? The number of hits stated as a fraction of all attempted accesses is called hit rate. What is it? The number of hits means how many successful accessing is possible through cache, means all the datas, how many datas are present in the cache, to the number of not present, total, not present, total, to the fraction of all attempted accesses. If I have searched 10 items, if I get 6 items within cache, then 6 by 10 is the hit rate, isn't it. Then what is miss? The number of hits which are not present, number of miss. The number of miss is nothing but what? Miss rate. Miss rate is what? The number of misses stated as a fraction of attempted accesses. Assume I have accessed the cache for 10 words. If 6 words I get, then 6 by 10 is hit rate. 4 miss occurs if the number, the word, if it is not, if the data is not accessed or if it is not present in the cache, then it is miss. So if the number of misses is stated as a fraction of attempted access, then it is miss rate. So among 10, 4 miss have occurred, so 4 by 10 is what? Miss rate, right? So what happens if number of hits are there, that is 6. What happens if 4 miss occurs? I have to pay extra amount of time now in order to fetch them from main memory and store it in the cache and then access it for execution. So miss penalty, what is miss penalty then? It is the amount of payment, the penalty what I am paying, isn't it? So what it means, what miss penalty means now? Yes, this is the amount of time, extra time needed to bring the desired information into the cache. The extra time needed to bring the desired information into the cache is called miss penalty. And this miss penalty is ultimately having an adverse effect on the performance of the processor because it is consuming more amount of time. So this miss penalty, I don't want this miss penalty, I want to improve the hit rate, I want to reduce the miss penalty, isn't it? So hit rate can be improved by increasing the size of the blocks, block size, the cache block size are to be improved, the size of the cache has to be improved, but I can't have a very big cache because it will have the effect on the cost. We need to consider cost also because the success of a computer is performance and cost also, isn't it? So price per performance will be evaluating, right? So the hit rate can be improved by improving the cache size, but cache size cannot be too larger because it affects the cost of a computer. So block sizes that are neither very small nor very large should be chosen, which will give the best results, right? Then miss penalty can be reduced if load through approach is used when loading new blocks into the cache. So this is how we can improve the performance of a computer, isn't it? Then the access time, average access time can be calculated by using this formula. T average is equal to H1 C1 plus 1 minus H1 into H2 C2 plus 1 minus H1 into 1 minus H2 into M. What H indicates? It is indicating the hit rate. What C is indicating? The time to access the information in the cache is denoted by C. Okay. So this is how we can calculate the performance of a computer, the average access time of a computer. Not only interleaving or parallelism only will improve the performance, other things which can improve the performance is write buffer, prefetching, lookup free cache. Okay. So moving to this, what write buffer is. So whenever write operations are to be done, if many writes are there, if many writes come one after the other, then what we can do is all of them should be stored in the write buffer so that I can write the things which are available in the buffer after my main operation which I am performing, so that it will not affect the performance. If writing is done immediately after changing the contents, okay, it will be consuming more amount of time and the processor becomes slow and it will not be doing any fruitful operation. That is another operation it is not doing now. So if I have a write buffer and if I store all the information which are to be written later, then by looking at the write buffer contents, if I going to write the things afterwards whenever the processor is free, then it improves the performance. That's why the write buffer is one means to improve the performance. So within write buffer, as we have two types of writes, one is write through and the other one is write back, isn't it? What is write through? Each write operation involves writing into the main memory. Writing is nothing but writing into the main memory. If the processor has to wait for the write operation to be complete, it will be slowing down, isn't it? So the processor does not depend on the result of the write operation. Write buffer can be included for temporary storage of write requests. Processor will place each write request into the buffer and continues execution. If a subsequent read request references the data, which is still in the write buffer, then this data is referred in the write buffer. See, I have a read request, and if that read request is the one which is already written in the main memory, then it is fine. If it is not so, if it is a new content which is not yet written in the main memory, then a problem will be created because the older data may be fetched. That is why whenever a write request occurs, a read request occurs, then that read request first will be compared to the contents of the write buffer. If it is already in the write buffer, then it will be taken and it will be read. So, first accessing will be given to write buffer instead of the main memory. So, this is write through. Then in write back, block is written back to the main memory when it is replaced. If the processor waits for this write to complete before reading the new block, it is slowed down. So, fast written buffer can hold the block to be written and new block can be read first. Okay. This occurs in write back. So, after this, the one more parameter which can improve the performance is by prefetching. Prefetching is fetching the things priorly before it is needed, before the read occurs, before a read call occurs or a writing is necessary, before reading the content, before read operation occurs, the content has to be fetched priorly. That is nothing but prefetching. Okay. So, new data will be brought prior to the cache when a read occurs. Okay. That is prefetching. Then comes to lookup free cache. So, lookup free cache, what happens within this, why we need this? Prefetching scheme does not work if it stops other accessing to the cache until the prefetch is completed. So, a cache of this type is said to have been locked while it services a miss. Whenever a miss occurs, the cache may be locked. Okay. So, cache structure which support multiple outstanding misses is called a lookup free cache. Since only one miss can be serviced at a time, a lookup free cache must include circuits that keep track of all outstanding misses. Special registers may hold the necessary information about these misses. This lookup free cache will be improving the performance if at all many number of miss occurs. So, if many miss have occurred, the performance may be delayed or the cache may be locked. In order to avoid this, lookup free cache is used. So, this is how the different parameters can be used or different methods can be used to improve the performance of a computer. Thank you.